middle values, or central tendency, and variation of values, or spread, for symmetrically distributed and non-symmetric. So there's 4 things. So for central tendency, we have the mean for symmetric, we have the median for skewed or non-symmetric. So that's 2 of them. Okay, here we have several descriptions or variations, and this is where the similarity for the IQR and everything. Hold on. So that one's not, that answer about the spread is not in the slide as blatantly as the first one is. But mean goes with what measure of variation? Mean plus or minus, and the median plus or minus. Yeah, so those are the ones that the question is looking for. So if some of you, I think some of you just put the middle values at mean for symmetric, median for non-symmetric, which is good, but then you didn't say anything about the variation. Some of there was an issue in general with people not reading the question. In some cases it was blatant. This is a little more subtle, and this was tricky. You kind of had to be very carefully read the question to get all of that it was looking for. Some of the misreads were more blatant, like simply someone just answered a completely different question than what was asked. And so your example, Yvonne, does not fall into that category. Or the explanation of it, or the one that I gave of somebody getting the central value but not the variation. But that is a source of a little bit. I think that got you 3 points off if you did that, out of 6. So I think the major loss of points was in the tables and the data, the significant figures, the sample sizes, and this sort of thing. And the histogram versus the box plots thing was a lot. That's 20 points. Okay? So one thing we can do is we can go through the whole test, but are there any specific questions before I do that? And is that useful? Do you want me to do that? We really have covered 2 and 3 already. Do we need to cover 1?
I have a question. I think you've already said this, but so you're going to go through and look at the test again? Like, are you going to?
Yes, I'm reviewing them this weekend.
So if I have other concerns, do I just email you?
Yeah.
Okay.
Sure. All right. So number 1. One person thought this was a multiple choice question. They didn't do well on that question. What is the expected answer for part A?
There's a population parameter.
Population what?
Parameters.
Say it louder, Cameron.
Population plus or minus the population.
Correct. And part B?
It's the sample mean plus or minus.
Sample mean plus the sample standard deviation. So for the camera, I'm probably couldn't hear. The first is population mean plus or minus population standard deviation. The second one is sample mean plus or minus sample standard deviation. Now, if you put that and nothing else, did you get full credit? Why not? What does the question also state? Huh? The differences on how they're calculated, correct. And so if you didn't mention that, you got, I don't know, 2 or maybe even 4 points taken off, I don't remember. Maybe 2. So what is the difference?
Population uses capital N.
Yes?
And the sample uses N-1.
Correct. So that needed to be on there. Okay. Now, number 4. What are the advantages of using graphs to present data? A, B, and D. Multiple ones are correct. Now, if you had studied the slides and the material presented in class, you would have known that it couldn't be a single answer here. The only one that is not true is C. That is something that a table does. It gives you the actual values instead of having to read them off of the axis as you would in a graph. So A, B, and D is the correct answer there. All right. Okay. So let's look at the answer key. Sorry. Okay, box plot was correct, and why is the box plot the choice?
There's less than 50 data points for each one.
Yes, and what about the number of groups?
It actually show more than one.
Huh?
It actually shows more than one group compared to the histogram.
Yeah, it's hard to do. Three, you could maybe do 3 with a histogram. When you're trying to compare groups, box plots often work a lot better, even with 3. But the main thing is the number of data points here. So so you're going to get, this came from Dr. B, -5 for each missing axis label. -5 for missing n values, -5 for missing figure, -2 if you don't have all 3 boxes in the same graph. That was the way it was graded, and so these are to get your attention. These are things that needed to be deducted. So. Okay. Any questions about that? Comments? Okay. Now, Dr. B said in class that he wants mean plus or minus standard deviation. You had to. If you didn't put units in your table, that is a big no-no, you know better, and that's another one of those things that we're going to be relatively draconian about. It means harsh, but it sounds better, draconian sounds better. Okay, and there's a descriptive title at the top. I didn't do the different colors, but it's good to bold the headings. Actually, I might have bolded these as well so that the viewer can easily see that they're not content. Description of the group and the sample size. And then the values had to be correct. If you got all the values correct, you got 15, and you could still miss 11 points for the formatting. The plus or minus symbol is one thing that Dr. B wants in there. Another thing is that if you have micrograms, you need to learn how to make them U. There's no micrograms in this table. But I don't know if this came up, but if you use MATLAB to do your quartiles, you would have gotten slightly different answers. The median is the same, but the Q1 and the Q3 would be different, so the IQR was different. Some people just gave the 5-number statistic and left out IQR. I think they got at least 3 points off for that, maybe more. Okay. And then the last is, what can you say about the data and how they are distributed? Any questions about the table? Yes?
So if we include the IQR and all the quartiles, are y'all gonna take off of that? Or
No, I did, but, you know, I need to look. I looked at that this morning and I didn't see the IQR. So if it's there and I missed it, then I will look at that. But do read the question. Give what it's asked. And if you're going to give something more than what's asked, make sure it's not in the way of what's asked. All right. In fact, really just don't do it. Just make sure you know exactly what the question is. All right, so what can you say about the data and how they are distributed? Are there any unusual or extreme values? Do the data suggest any particular difference between fracture strength of bones due to age? Justify your answers based on your descriptive statistics and graphs. Now, what determines whether something's an outlier or not? That's a good rule of thumb. That you can. It depends on the context, but that's the one that we covered in class, and that's the one that we wanted you to use here. To get full credit for this, you need to mention that. The other thing, okay, and then what about how the data are distributed? What kinds of properties can you see when you're describing the way the data is distributed? Which properties of distributions did we study in class? Okay, that's the central tendency, mean or median. What's another property?
IQR.
Which is a measure of?
Variation.
Spread, yes. So we can have IQR or standard deviation. What other properties are there? There's two others.
Percent coefficient variation.
Well, that's a measure of variation. It's not a new one. That's not the two I'm thinking of. Skewness and kurtosis. Now, we didn't really deal with kurtosis, but we did talk, we showed you kurtosis. It's about whether the distribution is flat or peaked. It's about how thick the tails are. You can't evaluate that too well from a box plot, but you can evaluate what property well from a box plot? Skewness. Can you evaluate it with a histogram?
Not as much.
If you've got enough data points, you can see skewness on a histogram. All it means is that there's more data on one side of the mean than the other. So there's a couple of things in a box plot or a histogram that tell you that there's skewness. And let's look at the box plot. Skewness is the opposite of, if a distribution is skewed, what's the opposite of being skewed? Symmetric. That's a better answer because a normal is symmetric, but you can have symmetric that isn't normal. So symmetric is the opposite of skewed. Now, so which one of these groups is most symmetric? The middle one, yes. Is it perfectly symmetric? Why not? Huh?
The whiskers are different lengths?
The whiskers are pretty, yeah, they're slight, but for me, what pops out more is that the line, what's the red line represent? Huh? The median, yes. It is, this part of the box is a little fatter than this part of the box. That's what jumps out at me. I think you're right, the top whisker is a little shorter than the bottom one. But yeah, but you got the right idea. What about this one? Is this one real skewed?
Not as much as the young is.
Correct. Correct. It's a little skewed, but not terribly. And yeah, the young has very uneven whiskers, and it's a little more pronounced, the unevenness in the box. So this one is somewhat skewed, but if the values were outside of 1.5 IQR, what would we see? Huh? Louder?
Outliers.
Yes, what would we see if there was an outlier? What would we see on this graph?
Maybe like little red crosses.
Yeah, there'd be a little red cross up here, at least in MATLAB, we're down here. Now, some people got one of those because when they copied from Excel, we have 10 here, 9 here, and 10 here. If you just put a box around all of them and paste them into MATLAB, then that middle column, MATLAB filled a 0 in there, but that wasn't part of your data. So I think some people got an outlier here by being careless with their copying. So points would be taken off for that. All right. So these are the main points that we wanted you to cover there. So this is Dr. B's answer. Not unusual or extreme. No unusual extreme values. All data appear to be within 1.5 IQR of the median. Middle-aged and elderly are pretty symmetric, fairly even. Median values are fairly close to the middle of the box. The young data has some skewedness because there's not particularly even lengths. Now, that was the most important part. That was 16 points, describing the distributions. Now, the suggestion that the elderly may have why does he say the elderly may have a lower fracture strength?
Is it because it's overlapping?
Because they're overlapping. Yeah. When we have an overlap like that, there's a lot of random variation in our sampling. We could have just by chance gotten lower numbers from this group and higher numbers from this group. It's a little less likely with this going up here. But between here and here, in a small sample size, the overlap is pretty large, especially between these two groups. So we're not 100% certain that they're different. And in fact, when we do tests of significance, there's hypothesis tests, and then there's tests of significance for between different groups. These are things we're going to cover later in the course. That's exactly what we're trying to do, is to come up with a quantitative way of deciding if we consider these to be different groups based on the statistics. And so we haven't studied that yet, but there is a suggestion that there's a trend of weaker bones as you get older. And so that would want to be pointed out. And then the last thing, okay, there's more overlap in boxes and whiskers between young and middle. Okay, I think he means okay. And what he's saying here is that these two are overlapping so much that they really might not be different at all. Even though there's a suggestion that there might be, there's so much overlap that they're really very possible there's not a significant difference. What would you do if you needed to know for sure whether or not there was a significant difference? And let's say you run one of these tests of significance and this doesn't show a significant difference. Would you be sure there's not a significant difference? What could you do experimentally? Repeat the study with?
More sample size?
Yeah, larger sample size. Larger sample size is going to help you find out those differences. Why?
Larger sample size increases the accuracy?
It reduces the accuracy?
As it increases the accuracy?
Increases the accuracy. Accuracy isn't a good word. We use accuracy for measurements. What does it do to the sampling distribution when you increase the sample size? Louder?
Raise like the sample distribution closer to the population.
So the distribution, okay, I'll just say, the distribution, when you increase the sample size, the distribution of the sampling distribution gets narrower, okay, which means you will, on average, have things closer to the mean. And you get a better estimate, which I think is what you were getting at when you said the word accurate. But we don't like to use that for statistics because we use it for measurement. Okay, I believe that's it for the quiz itself. Any more questions about the quiz? And Holly, what time do you have to leave?
Like 10 minutes.
You have to leave in 10 minutes? Okay. I'm going to pause here and take a few minutes to look at Holly's stuff. And anybody who wants to stay and talk about questions other than the quiz, then we can do that with the remainder of the time. So let me just spend a few minutes with Holly so she can go.